In this video, we are going to learn how to calculate the speed at which a point on the surface of the Earth moves due to its rotation. The Earth can be considered as a sphere with radius 6,378 kilometers, and it is rotating around its axis of rotation. The axis of rotation is an imaginary line that passes through the center of the Earth and the poles of the Earth, namely the North Pole and the South Pole. As a result of this rotation, all points on the Earth's surface are moving in circles around the axis of rotation. The time taken for any point on the Earth's surface to complete a full circle is 24 hours. The plane of each circle is perpendicular to the axis of rotation. The plane of the equator is simply the largest of these circles. If we take the plane of the equator as a reference, then the position of a circle on the surface of the Earth can be identified by an angle beta called the latitude. The latitude angle beta is defined as the angle between the plane of the equator and a line from the center C of the Earth to the circle. For beta equals to 90 degrees, the latitude is called the North Pole. For beta equals to 23.4 degrees, the latitude is called the Tropic of Cancer. For beta equals to 0 degrees, the latitude is called the Equator. For beta equals to minus 23.4 degrees, the latitude is called the Tropic of Capricorn. And for beta equals to minus 90 degrees, the latitude is called the South Pole. Now let us consider the Earth as a sphere with center C. Consider a point P located on the surface of the Earth. The distance of point P from the center C of the Earth is equal to the radius capital R of the Earth. The radius of the Earth is 6,378 kilometers, and therefore we can write capital R equals to 6,378 kilometers. Due to the rotation of the Earth, the point P is moving in a circle with center O situated on the axis of rotation. The radius R of the circle on which the point P is located is equal to the perpendicular distance from the point O to the point P. The 3 points C, O, P form a right angle triangle. The latitude angle beta of the circle on which P is located is the angle made by the line CP with respect to the plane of the equator. The angle CPO is equal to beta due to the property of Z angle. From trigonometry, we can write R equals to capital R cos beta. The radius of the circle on which the point P is located depends on the angle beta. For beta equals to 90 degrees, which corresponds to the North Pole, we have cos 90 equals to 0, and therefore we have R equals to 0. This is because the North Pole is located exactly on the axis of rotation. For beta equals to 23.4 degrees, which corresponds to the Tropic of Cancer, we have cos 23.4 equals to 0.918 to 3 decimal places. And therefore, we can write R equals to 0.918 capital R. For beta equals to 0 degrees, which corresponds to the equator, we have cos 0 equals to 1, and we have R equals to capital R. A point on the equator is furthest from the axis of rotation, and its distance from the axis is equal to the radius capital R of the Earth. For beta equals to minus 23.4 degrees, which corresponds to the Tropic of Capricorn, we have cos minus 23.4, which is equal to 0.918, and we have R equals to 0.918 capital R. And when we have beta equals to minus 90 degrees, which corresponds to the South Pole, we have cos of minus 90 equals to 0, and we have R equals to 0. The South Pole is located on the axis of rotation of the Earth, and that is why R equals to 0, same as the North Pole. To find the speed of a point on the Earth's surface, we need to remember the mathematics behind circular motion. Consider a point P moving on a circle with center O and radius R. The distance of the point P from the center O is constant and is equal to the radius R of the circle. The vector from point O to the point P is called the radius vector OP, and its magnitude is simply equal to the radius R of the circle. The blue arrow is the velocity vector, and its magnitude is V, which is the speed. The speed V of the particle P is related to the radius R of the circle on which it is moving by the equation V equals to omega R, where V is the speed, R is the radius, and omega is the angular speed. Remember that velocity is simply speed with a direction, and therefore angular velocity is angular speed with a direction. A particle is said to be undergoing uniform circular motion when its angular velocity is constant. This means omega equals to constant, and the direction of the angular velocity vector is also constant. From the equation V equals to omega R, if omega is constant, then we can conclude that V is also constant. Therefore, a particle undergoing uniform circular motion, its speed is also constant. In this case, we can define a quantity called the time period capital T. The time period capital T is the time taken for the particle to complete one full circle. Over one time period capital T, the radius vector OP swipes through an angle of 2 pi at constant angular speed omega. Therefore, we can write omega times capital T equals to 2 pi, which we can rearrange as omega equals to 2 pi over capital T. We can substitute omega equals to 2 pi over capital T into the equation V equals to omega R and obtain V equals to 2 pi R over capital T. It is this equation that we are going to use to find the speed of a point on the surface of the Earth. Now let us return back to our Earth model. We can apply the equation V equals to 2 pi R over capital T on the point P to get its speed. Now let us substitute R equals to capital R cos beta into the equation V equals to 2 pi R over capital T to obtain V equals to 2 pi capital R over capital T cos beta. The time period capital T is 24 hours and capital R equals to 6,378 kilometers. Substituting these values, we have V equals to 2 times pi times 6,378 divided by 24 cos beta, and this is going to be in kilometer per hour, and we should obtain 1,670 cos beta in kilometer per hour to 3 significant figures. For any latitude beta, we can obtain the speed of a point on the surface of the Earth. For beta equals to 90 degrees, which corresponds to the North Pole, we have cos 90 equals to 0, and therefore V equals to 0. A point on the North Pole is not moving due to the rotation of the Earth. For beta equals to 23.4 degrees, which corresponds to the Tropic of Cancer, we have V equals to 1,670 cos 23.4, and this is in kilometer per hour, and we should obtain 1,530 kilometer per hour to 3 significant figures. For beta equals to 0 degrees, which corresponds to the equator, we have cos 0 equals to 1, and we have V equals to 1,670 kilometer per hour. So a point on the equator is moving the fastest. For beta equals to minus 23.4 degrees, which corresponds to the Tropic of Capricorn, we have V equals to 1,670 cos of minus 23.4, and this is in kilometer per hour, and we should get 1,530 kilometer per hour to 3 significant figures. And for beta equals to minus 90 degrees, which corresponds to the South Pole, we have cos of minus 90 equals to 0, and we have V equals to 0. A point on the South Pole is not moving due to the rotation of the Earth.